Mars 2020 mission is very important for JPL. They are sending a rover to Mars to drill and cache samples that could one day be sent back to Earth. And it's such a great feeling to be able to conduct research here at UC Merced that is assisting this mission.
The project we have going on with NASA JPL is focused on the 2020 Mars mission, and it has to do with movement that has to happen for mechanical components that will operate in the Mars environment. And in order for that movement to happen, they need to be able to slide easily relative to one another. And the 2020 Mars mission will rely upon mechanical components that can't be maintained. There won't be people up there to repair the components once it arrives on Mars. Unfortunately, the traditional mechanisms and the approaches that we use in engineering here on Earth aren't necessarily applicable on Mars. So we have to ensure that all of the mechanical components on the Mars 2020 project have high efficiency and works for as long as necessary in the Mars environment without maintenance. A former graduate student of mine, Duval Johnson, is now working at the Jet Propulsion Lab in the Applied Tribology Laboratory. And he actually brought this project to us, and now we're working together on the Mars 2020 project.
So the Robotic Arm is a multi-jointed system that has a percussive drill on the front of it. The percussive drill will have the ability to drill into rock, to collect samples that will then be put into the sample tubes and sealed. We have several components, the sample tubes being the most important of this system. These sample tubes interface with other components using ball lock mechanisms, and the ball lock mechanisms are absolutely critical in making sure that we can pick up a tube, put the tube where it needs to be. And so these sample tubes are put inside of a coring bit and then put in other places around the rover and eventually dropped on the surface. So UC Merced is helping us more with the adaptive caching assembly and its mechanism actuations with the ball lock mechanisms.
My work is experimental tribology. This is the study of friction, lubrication, and wear. I check the performance of lubricants and explore different surface engineering techniques to reduce friction and wear on lubricants that might be liquid lubricants or solid lubricants or dry film coatings, which currently are being used for the Mars rover mission. For this work, NASA sends us samples that are made by the same material that are used in the components in the Mars rover. These samples are coated with the dry film lubricant that they plan to use in those components. I test these samples in our tribometer, which essentially rubs two materials together and measures the friction force between them, and also allows us to look how much of material we have worn on this surface. Based on the results I gather from these testing, I can help NASA understand if these coatings can perform the way they want it to on the surface of Mars.
In the extreme environments of space, it is absolutely critical to understand how these materials are going to interact in cold, warm, very low humidity environments. If our actuators don't work properly, if our materials don't interact as they should, and we have some unexpected results, it could be a mission critical type thing.
It's very exciting and encouraging, and we're all pretty enthusiastic about participating in the Mars 2020 project here at UC Merced. We're happy that we're able to contribute in a very meaningful way to something that's very tangible and in the very near future.
It gives me immense pride to be working with NASA. I, as a child, was always curious about space, and now I'm working on research at UC Merced for NASA, and that gives me immense satisfaction.
It feels good to be a part of something that has the ability to increase our knowledge of other planets and their creation and formation and life that have possibly been there before. It just feels good to be a part of something that's bigger than just this Earth.